Imagine, if you will, a journey, not to distant stars, but deep within, beneath the crushing pressures of the Atlantic, near a place mythically named Atlantis Massif. Here in the year 2025, humanity has just touched the forbidden. For the first time, our drills, extensions of our curiosity, have directly pierced Earth's mantle, that vast, mysterious layer beneath the crust. The Earth's mantle. It's a colossal engine, hidden from our view. Comprising most of our planet's volume, its slow, churning currents drive continents, birth volcanoes, and shape ocean basins. To understand it is to understand Earth itself. The samples brought to the surface, these emissaries from the deep, are more than mere rock. They are time capsules, holding tales from Earth's fiery youth billions of years ago. This is not just geology, it's a journey back to the dawn of time, a new chapter in Earth's biography. These mantle rocks, born of fire and pressure, promise to reveal the planet's deepest secrets. The mission, aboard the research vessel JOIDES Resolution, had a plan, a carefully charted course. They aimed to drill some 200 meters, a bold goal in itself, into the ocean floor. But Earth, it seems, had other ideas. The drill bit, guided by human ingenuity, found an unexpectedly accommodating path. It kept going, deeper and deeper, far surpassing the initial modest target, plunging into the truly unknown. Imagine the scene on the ship, scientists, engineers, minds focused. Then the numbers kept climbing. 200 meters, then 500, then 1,000. Finally an astonishing 1,268 meters, over a kilometer straight down into Mantle rock. This wasn't just a success, it was a record-shattering leap. The Earth, in this specific location, near the Atlantis Massif's strange geology, yielded its secrets more readily than anticipated. The planned, modest sip from the Earth's interior had turned into a deep, revealing draft. And what of these rocky messengers themselves? They weren't dull, gray, or featureless. Oh no, the core samples emerged with a captivating, shimmering green hue, like veins of polished jade or some otherworldly green marble. This vibrant color was an immediate clue, a geological fingerprint telling a story of profound transformation deep within Earth, a story written in stone and water. This beautiful green is the signature of a process called serpentinization. It's a slow, elemental alchemy. When seawater over millions of years percolates down through cracks in the ocean crust, it encounters the mantle's native rocks, minerals like olivine and pyroxene and peridotite. A chemical reaction ignites, transforming them into new minerals, including serpentine, the source of that green. These green rocks are like nature's notebooks, filled with chemical breadcrumbs, as scientists say. They chronicle the long interaction between the ocean and the planet's hot interior. Studying them reveals secrets about Earth's deep water cycle, how water is drawn down and expelled. It helps us understand how certain valuable mineral deposits might form, hidden beneath the crushing ocean depths. The location of this extraordinary drill site is no accident of geography. It lies near a truly wondrous place, the lost city hydrothermal field. Imagine on the dark abyssal plain towering spires of ghostly white carbonate. They rise like ancient submerged cathedrals, venting warm alkaline fluids, rich in chemicals from deep below. A unique ecosystem unlike any other. The lost city is not powered by volcanic heat like the more famous black smoker vents. Its engine is serpentinization, the very same process that painted our drill cores green. The mantle rocks beneath, reacting with seawater, generate the heat and the chemical-rich fluids that sustain this remarkable oasis. The hydrogen and methane produced are food for microscopic life, forming the base of a unique food web. This connection is profound. The drilling didn't just find green rocks, it tapped into the geological heart that gives life to the lost city. Section 5 Secrets of the Seafloor, Spreading Reading Earth's Diary. So this grand drilling expedition, it unfolded beneath the waves of the mid-Atlantic ridge. Now this isn't just any patch of ocean floor, folks. It's a colossal underwater mountain range, snaking its way down the Atlantic's spine. Here, Earth's tectonic plates, those giant jigsaw pieces of our crust, are relentlessly pulling apart. It's a slow yet immensely powerful separation. As these plates diverge, molten rock or magma wells up from the mantle below. It cools, solidifies, and forms new oceanic crust. This is what we call seafloor spreading, the engine that constantly renews the ocean floor. The Mid-Atlantic Ridge is, well, it's like a planetary construction site, a natural laboratory for studying how our world continuously remakes itself. Drilling here offers a direct window into these fundamental geological processes. The core samples retrieved are, you could say, a geological tapestry. They include rocks like Hartsbergite, a type of peridotite, which is the main stuff of Earth's upper mantle in these regions. Section 6, Against the Grain when progress outpaces plans. One of the most startling revelations from this deep-sea endeavor was not just what they found, but how quickly they found it. The drill, a marvel of engineering, sliced through the hard mantle rock at a pace that astonished everyone. It was roughly 3 times faster than the scientists had dared to predict. This was progress on an unprecedented scale. Now this rapid penetration wasn't reckless abandon. It was a testament to advanced technology and perhaps to the specific conditions at this unique geological site. It challenged long-held assumptions about the sheer difficulty of boring into our planet's deep, dense layers. For decades, the mantle was seen as almost impenetrably tough. This mission suggested a different story. The drill wasn't out of control, it was outperforming every expectation. This happy surprise meant more core samples, more data, more scientific bounty than the team had budgeted time or resources for. Section 7. Grazing the Great Divide, the elusive Moho. For nearly a century, Earth scientists have chased a geological ghost, the Mohorovisic discontinuity, or Moho. It's not a place but a boundary, a seismic shift in density that marks where Earth's crust ends and the mantle truly begins. To drill through the Moho to sample pristine, untouched mantle rock from below that line has been a holy grail. The intrepid team aboard the JOIDES Resolution harbored this grand ambition. They hoped to be the very first to punch cleanly through the Moho in a typical section of oceanic crust. While they achieved a historic depth and brought back bona fide mantle rocks, they didn't quite cross that specific threshold in an undisturbed crustal sequence. The mantle they sampled was exhumed, brought closer to the surface by ancient faulting. So, while the classic Moho transit remains elusive for now, they came breathtakingly close. They grazed this great divide, providing an unparalleled glimpse of what lies just beyond our crustal skin. Section 8. A Glimpse Interrupted, the Economics of Discovery. Just as this extraordinary mission was rewriting textbooks, as the green cores of mantle rock were piling up, promising untold revelations, the story took a frustrating turn. The engine of discovery, it turns out, runs not just on curiosity and ingenuity, but also on something far more terrestrial: funding. And the funding ran out. The expedition was forced to conclude prematurely. The decision, reportedly from the National Science Foundation, to curtail its financial support for the drilling vessel's operations came as a blow. Here was a project exceeding all expectations, delivering groundbreaking science on the cusp of even greater insights. Yet, the complex realities of budgets, of allocating finite resources across many deserving scientific fields, brought the drilling to a halt. This is a poignant reminder. Big science, the kind that pushes boundaries and ventures into the unknown, is a costly long-term commitment. Section 9. The Next Frontier. Our journey to the Earth's core continues. These remarkable green stones, wrested from Earth's deep embrace, are more than just geological specimens. They are keys, capable of unlocking some of the most fundamental secrets of our planet. They offer a direct line of inquiry into the processes that govern Earth's very being, from the majestic dance of plate tectonics to the creation of the ground beneath our oceans. The story is just beginning. With these samples, we can probe the intricate mechanics of how continents drift, how mountains rise, and how oceans are born. We can refine our models of the planet's chemical composition and its thermal evolution over the vast expanse of geological time. And perhaps most profoundly, the chemical reactions like serpentinization, recorded in these rocks, echo conditions that might have nurtured life's first fragile spark. But to truly unravel these planetary mysteries, our journey into the Earth must continue. This expedition, for all its record-breaking success, was but a single, albeit glorious, step. The mantle is vast, its variations largely unknown. What other wonders, what other processes await our discovery in its depths? Only through sustained exploration, through bold new missions and technological leaps, will we find out.